Let's say that we ran the data for the semester grades question in using SPSS. I want to show you what the output would look like and how you interpret it. So there's a couple of things here. This very first box, has some useful information because it tells you the sample size, the mean of the sample, standard deviation, and the standard error of the mean. Okay. Now, let's look at this one because this one gives you the actual results of your t-test. Here, the test value, remember that's what SPSS calls the constant. So 85 is the constant. And these are the actual results of the t-test. So your t-value is negative 0.71, 14 degrees of freedom, and the sig value, which is the same thing as the p-value, all right, that's the probability of making a type 1 error if you reject HO. All right, so if we reject HO, we have up to this level of chance of making a type 1 error, and it's unacceptable. Remember, we usually set the p-value, or I should say set alpha, at 0.05 or 0.01. Which means we're only going to reject HO if our risk of a type 1 error is less than 5% or 1%. But here, this is 11%. All right, so there's up to an 11% chance of making a type 1 error if we reject HO. So what are we going to do? We're going to retain HO, right? And say that the results are not significant. Now, there's something I want to introduce you to here. And that is the measure of effect size for t-tests. And the statistic that measures effect size for t-tests is Cohen's d. And we have here calculated Cohen's d at 0.44. Now, the reason why I didn't have you calculate Cohen's d when you did the SPSS assignment is because SPSS doesn't calculate it, which has been a huge complaint among SPSS users. But there are apps online that can calculate it for you that are really simple and easy to use. The key to using them, though, is you have to use the right Cohen's d formula. And that's because there's a Cohen's d formula for the one sample t-test. The formula is different if it's a dependent t-test, and there's a third formula for the independent t-test. So if you're Googling an online app to calculate Cohen's d for you, make sure that you include in your search Cohen's d for a single sample t-test or Cohen's d for a one sample t-test. Otherwise, you're going to have a chance of calculating it incorrectly. So what does the 0.44 mean? Well, let me just start off by saying the higher this number, the greater the effect size. In other words, if we see a difference between our mean, right, the 80 here, and the 85, the bigger the Cohen's d, that's saying that the stronger that effect size is. There's a huge effect of semester on grades. And so now we have to ask ourselves, well, how big is 0.44? Is that a big effect size? And generally, no. All right, so here's just a very simple guideline, oversimplified guideline, some would say, of effect size that reflects small, medium, and large effect size. Okay, so 0.44 is closer to 0.50, but keep in mind that our t-test was not significant. So the fact that our t-test is not significant kind of suggests that, well, even though this was maybe leaning towards a moderate effect size, it still wasn't big enough to reach that conventional level of significance. All right. Another thing I want to mention here is, let's say that we did have a violation previous to running this test. Let's say, again, it was the violation to normality, and we get a non-significant t-test result. Well, at that point, we really don't care whether we had a violation to the assumptions. All right, we only care about violations to assumptions if the t-test or the ANOVA itself was significant. Then we care. Okay, so the fact that we didn't get our t-test to be significant, we kind of couldn't care less about what was going on with the assumptions themselves.